Till now, we have done 3 elementary operations or transformations due to rows. Similarly, we have 3 transformations due to columns. First is interchange of any 2 columns, which is given by the operation Ci get interchanged by Cj. Second is multiplying elements of the column by a non-zero number, that is Ci changes to k times Cj, where k is non-zero number. And third is adding a column or a multiple of a column to other column. Well students, now the question is, what is the use of these elementary operations? Actually, these elementary operations are used to find inverse of a matrix. And yes, we can find inverse of a square matrix by elementary operations if it exists. And one thing more, we can find the inverse of a matrix if it exists by using either elementary row operations or elementary column operations, but not both simultaneously. Means in a question, either we have to use operation on rows or we have to use transformations on columns. We can't use them altogether. Now let us see that how inverse of a matrix can be found by using transformations. And let us start with transformations along a row. Let A be an invertible square matrix of the order n. Then we can write A equals to In into A, where I is the identity matrix of the same order. Now, by applying elementary operations along row on matrix A in left hand side only, we can reduce matrix A to identity matrix of the same order. But to maintain the equality, we have to bring about necessary changes in right hand side so that their product becomes equals to identity matrix. So here we apply same elementary operations along rows on I so that it gets converted into B, whereas A will remain as it is, such that their product equals to identity matrix of the same order. So we get the result In equals to matrix B into matrix A. Now next is post multiplying by A inverse, means In identity matrix into A inverse equals to B A into A inverse. Post multiplying means A inverse should be multiplied after In and after BA. In case of pre-multiplying, then A inverse should come before In and before BA. Since it is post multiplication, that's why A inverse will be applied after In and after BA. Since multiplication of matrices is associative, so we can write right hand side as matrix B multiplied by the product of A into A inverse. And the left hand side, which is I into A inverse, will become A inverse only. So we get A inverse equals to Bi. It is because A into A inverse equals to identity matrix of the same order. Now we can write this as A inverse equals to matrix B. So here inverse of matrix A is matrix B. That is how by using transformations we can find inverse of a matrix. In next section we will do some questions on elementary operations. Thank you.